Welcome back. This lesson is about the equilibrium expression and the equilibrium constant. So first let's talk about the expression. So Kc is what we call, and we're going to calculate it in just a second, is the equilibrium constant, and that equals the concentration of products over the concentration of reactants, where coefficients become exponents. So if I have this reaction, A plus B produces C plus D, here is my expression. Kc equals concentration of products, C times D, where coefficients become exponents, over A times B, where coefficients become exponents. Okay, that is the equilibrium expression for that reaction. So let's look at another reaction. And this is similar to what I showed you in a previous video. Okay, so what's the expression? If I said to you, what is the expression? Here's what you'd write down. Kc equals products over reactants. Kc equals concentration of ammonia squared, coefficient becomes exponent, over N2 times H2 cubed. Okay, that's Kc. And that's it, that's the expression. Now, I can still plug in numbers to this and actually find a constant. So let's say I had 0.2 moles per liter of nitrogen, 0.4 of hydrogen, and 0.1 of ammonia. I plug in my numbers. So products, ammonia, 0.1 squared, over reactants, 0.2 and 0.4, and 0.4 is cubed. And then I get my value. 0.78 is my equilibrium constant for that reaction after it's hit equilibrium. Okay? All right, the odd thing here is we don't need units because of the coefficients becoming exponents, like you'll have moles per liter times moles per liter divided by moles per liter cubed. Every time we did this, we'd have different units. Moles per liter squared, cubed, 1 over moles per liter squared. So it's acceptable to just remove them and understand what the constant is. Okay? It's like the only time in chemistry we do that. Okay, so normally it's no units. Also, a couple things. Do not include solids in the expression. You chuck a rock in water, it doesn't dissolve. What's its concentration? Well, it didn't dissolve. It doesn't have a concentration. Okay, and that's for your assignment. And only include liquids if every entity is liquid. Okay, so if I said write the expression for the following, okay, there it is. Kc equals Hi squared over H2 times I2. That one's straightforward. Let's look at this one. Products, H2 squared over or times O2 divided by H2O squared. Oh, be careful. That's a liquid. You can't include that. All right, unless they're all liquids. Okay, so there we go. A couple other things. Kc is greater than 1. Products are favored. So if Kc is 1.56, greater than 1, that means products are favored. It just means the concentration of my numerator is greater than the concentration of my denominator. Okay? So products are in greater concentration. This equation favors products. Okay? So if you take a look, 5 is greater than the other ones, which are 2. Okay? All right, and if Kc is less than 1, that means reactants are favored, which just means reactants are in a greater concentration. Okay? Reactants are favored. Okay? So 0.6 is greater than the 0.1. Okay? Numerators and denominators. Good. Okay, the next lesson we will talk about 3 types of equilibrium calculations.